For this lesson, we're going to be looking at our second type of sequence, and that is a geometric sequence. So in a geometric sequence, the ratio of our consecutive terms is constant. So this is also called a common rate, common ratio. If you're looking at other texts other than just our textbook, you might see those terms. So they're all referring to the same thing. So for example, if I look at this first sequence, I have 2, 10, 50, and 250. So to get from 2 to 10, I would multiply by 5. To get from 10 to 50, I would multiply by 5. And to get from 50 to 250, I would also multiply by 5. So because each time I multiply by 5, the common ratio is 5. Now let's look at the second one here, and just to have an example that is not a geometric sequence so you can see the difference. So in this case, to get from 2 to 6, we would multiply by 3. To get from 6 to 24, we would multiply by 4, and already that is enough to tell us that this is not a geometric sequence. We can do another one just to verify it 100% and know for sure that we didn't make a mistake, but if all of the ratios are not the same, it is not a geometric sequence. So in general, the first term in a geometric sequence is a, and the common ratio is r. Then we would have a times r squared, a times r cubed, and so on and so forth until we end up with a times r to the power of n minus 1. We also write this as T1, T2, T3, term 4, etc., just like we did with our arithmetic sequences too. So in general, our formula for a geometric sequence is Tn equals a times r to the n minus 1. So now let's use this in a few examples. So for example 1, we're going to first find the formula for the nth term of 2, negative 6, 18, negative 54. Then we'll find T10 or the 10th term. So to start, let's find that common ratio. So we have 2, negative 6, 18, negative 54, and then this continues on. So to get from 2 to negative 6, I'd multiply by negative 3. Then to get from negative 6 to 18, I also multiply by negative 3. And then to get to 18 to negative 54, I also multiply by negative 3. So we've learned two things here. One, this is definitely a geometric sequence. And two, that our common ratio, or r, is negative 3. Now our a is just our first term, so we see that here, so our a is just 2. So now we have r and a, which means we can fill out our general formula. So our nth term is equal to 2 times negative 3 to the power of n minus 1, just like that. And now I need to find the 10th term, so T10, or my 10th term, is equal to 2 times negative 3 to the power of 10 minus 1. So I can just simplify that exponent now, like that, and then I can just put that in my calculator. Just be careful with that exponent that it's only applied to your 3 when you're plugging in your calculator. So if you realize you're getting answers wrong in your calculator, just let me know because you might just be typing it in wrong. So when I type that in my calculator, I'll get that my 10th term is equal to negative 39,366. So now let's do another example. So example 2 is asking us, how many terms are there in the following sequence? So I have 4,374, 1,458, 486, and I get all the way down to 2. So we know we end at 2, but we don't know how many terms are in this sequence. So the first thing we need to do is we need to find our general formula. So let's start by trying to find our r. So I need to think, how do I get from 4,374 to 1,458. So because my numbers are getting smaller, it means that I'm going to be multiplying by a fraction or dividing. So in this case, to get from 4,374, I would multiply by a third or divide by 3. Because of the nature of a geometric sequence, we always want to talk about multiplication, but those two things, multiplying by a fraction or dividing by a number, are the exact same thing. So if I try it again with our next two terms, I would also multiply by a third. So again, we've proved that this is geometric, which is great. And then we've also found our r, which is a third. Now our a value is our first term, which in this case is 4,374. So now let's start by writing our general formula. So we have our nth term is equal to 4,374 multiplied by 1/3 to the n minus 1. Now, we know that our last term is 2, and we want to figure out what number that term is. So that means that we're looking for n. So we know our last term is 2, so I can sub that in for t to the n. And I'm looking for n minus 1. So now let's start simplifying this. So we're going to divide both sides by 4,374. So 2 over 4,374 is equal to 1/3 to the power of n minus 1. Now let's reduce that fraction there, the 2 over 4,374. So that would give me 1 over 2,187. Now in order to solve for n, because it's in the exponent, the only way I can do that is to have the same base. So now what I have to start doing is looking at this 1 over 2,187 and thinking of how could I make that have a base of a third. So basically I'm going to take 3 and I'm going to find all my powers of 3. So there really isn't a better way to do this than to guess and check. So I'm just going to start guessing. So 3 to the power of 5 gives me 243, which is too small. 3 to the power of 6 gives me 729, still too small, but we're getting there. 3 to the power of 7 gives me 2,187, which is exactly what I want. So 1 over 2,187 is the exact same as 1/3 all to the power of 7, and that equals 1/3 to the power of n minus 1. So the only way for these two to possibly be equal is for my exponents to be the same. So 7 must be equal to n minus 1. So now we can solve for n. So let's get that n all by itself so that 1 goes over to the other side. So we'll get 8 equals n. So that means that this 2 here is the 8th term. So I can write, therefore, the sequence has 8 terms. Okay, let's try another example. We have 2 more. So example 3 tells us that the third term is 3 and the 8th term is 3,072, and that they are in a geometric sequence. So the first thing we need to do is find our general formula for the nth term. And then once we have that, we'll find the value of our 7th term. So let's start by finding our nth term. So in our question, we're given 2 specific situations. The first one we're given is that 3 is our third term. So we don't know A, we don't know R, but we do know that that is our third term. So I can simplify that. There we go. Oops. 3 minus 1 is 2. Sorry about that. And we are also given the situation that the 8th term is 3,072. So we know that our 8th term is 3,072. So again, we don't know A and R, so we'll just leave them. So now I have two equations with two variables, which means I can solve this using substitution or elimination. In this case, because I don't have things being added, elimination isn't really a good choice. So I'm going to use substitution. So I'm just going to rearrange my pink equation so that I isolate A. So we'll have 3 over r squared equals A. And now I'm going to take that value for A and sub it into my other equation. So instead of writing an A here, I'm just writing 3 over r squared times r to the 7. So again, all I did is I just took this A value and put it in over there. So now let's simplify that and solve for r, because now we only have one variable. So we can solve that. So we'll have 3072 equals 3r to the 7 over r squared. Now we know our exponent laws. So because I have two things with the same base, I keep my base and I subtract my exponents. So 7 minus 2 is 5. So now to isolate r, I need to divide out that 3. So let's divide out that 3 on both sides. So 3072 divided by 3 will give me 1024 equals r to the power of 5. And now, if this were a 2, everyone would tell me that my next step is to square root. Now we can do the exact same thing even though it's a 5. Just instead of doing a square root, we do a fifth root. So you can see how everything comes full circle in this unit. So you can do that on your calculator too. Or if you can't figure out how to do that on your calculator, you can always type in to the exponent of 1/5. That also works too. And when I do that on my calculator, I'll get that 4 equals r. So now I needed values for a and r. We're halfway there, we have r. So let's use that r value to find a. So that gives me 3 over 16 equals a. It's not a particularly nice number, but that's okay. So now we know that our general term, so our nth term is equal to 3 over 16 times 4 to the n minus 1. And now B asked us to use that general formula to find our 7th term. So we're looking for our 7th term, which would be equal to 3 over 16 multiplied by 4 to the 7 minus 1. So we'll have 3 over 16 times 4 to the 6. And I'm just going to put that in my calculator, and I will get 768. Therefore, the 7th term is 768. Okay, one more quick example, and this one is an application question. So each year, for 10 years, the population of a city increases by 5% of its value in the previous year. If the initial population is 200,000, what will the population be after 10 years? So let's start by making our general formula. So we need to find r, and this is actually very similar to when we were looking for our growth rate in exponentials. We know that it increases by 5% each year, so we're looking for a growth rate. So we add 1 to the decimal. So our growth rate, or our common ratio in this case, is 1.05. And our first value is our initial value, or initial population, of 200,000. So now our general term would be 200,000 times 1.05 to the power of n minus 1. And you can see how this is kind of looking like an exponential now too. So again, you can see how all of our units are intertwined and connected. So now I want to find out what the population will be after 10 years. So I'm looking for my 10th term of the sequence. So I'm just going to sub in 10 for n, like that. And I can simplify that exponent. And then I just put that whole thing into my calculator. And I will get 310,265. Now there are decimals here, but we do not use the decimals when we're talking about people because we can't have 0.5 of a person. So our therefore statement will say, therefore, there will be 310,265 people in 10 years. And that is our final answer.